Rise and shine, explorer. Today's the day we've been working towards. We're finally ready to ascend from the ocean depths and glide our spaceship back up to the watery surface. I hope you're as thrilled as I am. The past few weeks have been a test of your courage, determination, and your ability to think on your feet, and I must say, you've handled every challenge with intelligence and tenacity. You're proving to be a true explorer in every sense. But remember, there is still much work to be done. Today, we will put everything we've learned to the ultimate test. All of your wiring, coding, and problem-solving skills are going to play a crucial part in our endeavor today. So, take a deep breath, clear your mind, and prepare yourself. Today, you're more than an explorer and an engineer. You're a brave starship commander, navigating tenaciously through the unknown. Strap in, explorer. It's going to be a thrilling ride. Are you ready? It appears we're all set to make our careful ascent back up to the water surface. It's critical we do this gradually to prevent our shuttle from popping like a balloon under the change in pressure. Do you recall our trusty sidekick, the passive buzzer? I'd suggest we reintroduce him into our circuit as an additional safety measure. He'll be our alarm bell, warning us if we're ascending too quickly. Don't fret, I've got you covered with all the guidance you'll need, conveniently located in your mission resources. And guess what? They're ready for playback right now. Beginning playback.
Hello, everybody, and welcome back to day 19 of the 30 Days Lost in Space Adventure Kit code explanations. Now, a lot of this code that we put in is from day 18. I'm not going to be going over that code from day 18. So what we can do, we can simplify a lot of this by removing a lot of comments and going down and explaining what's already known. Obviously, we have these functions at the bottom. Nothing's changed there. We have a lot of new functionality inside of our loop. But besides that, there's actually not a whole lot of new things. This is all the same from setup from yesterday. I could actually just go bloop, close that up, not necessary. We also have a constant byte done. But we've also got nope, and then we also have a new one for today called hold. And as you can guess, it works the exact same way as the other two. So I'm just going to close that down. And that's just going to be another one that we can show off later on once we show off our code. We have the keys. Make sure you have these in here. If you don't, it will not work. Same as up above. The only new thing that we have up above for this entire top part is we have the constant byte buzzer pin is going to be equal to 10. Today we're going to be introducing a buzzer so that we can have additional alert sounds whenever we hit certain depths so that we know not to rise too quickly back up to the surface. Now, what we can do is we can actually, instead of using those variables like we had yesterday, we can actually use percentages. So we know that we're going to have to stop at about 50% of the way and 75% of the way. So we want to alert the user when we have risen to 50 and 75% of the way up. So instead of before we had negative 20 and negative 40, we're going to be using this instead. This is the same. We also have a constant unsigned int loop delay equals 200, which is 200 milliseconds that we're going to add as a small little buffer for our interrupts between the loop executions. Inside of the loop, we have the following. Static int previous depth is equal to initial depth. And this is just going to give us our depth from our previous loop. Now, if there was a change, obviously this is similar, same thing as yesterday. If there was a change in the depth level, meaning you turned that rotary encoder at some amount and risen us at least a little bit, probably just one. If there was any change in that, we're going to go through this loop, grabbing the current depth just like yesterday, and then we're going to compute our percentage of the way up. Now, yesterday we were saying what the depth level was, but instead we're going to give us a percentage from 0 to 100. In order to calculate that, we can take the current depth times 100 divided by the initial depth, and then do 100 minus that entire total. That will give us the percentage of the way to the surface that we've gone so far. Now, rising too quickly could stress the hull of our lander. Because of this, we will play an alert if the lander is instructed to rise faster than 1 meter every time through our loop. We need to be sure that we're not going too quickly. So, let's just say you went through the loop and you spun it really quick. And so you went from 1 to 4, all in that 1 second. Hey, we're going to have a buzzer pin go off that tells us that we need to chill out for just a minute. You're going a little too fast. This is the same logic as before, which simply just says if the current depth is less than the initial depth, don't try going down because Mr. Wise Guy. We then have the function to show that number, whatever the depth is, on our 7-segment display. And then we finally have the same thing as before. If we've hit the very first 50% mark or the 75% mark of our way up to the surface, we want to display our depth is a little blink on the display. And finally, we're going to display done, assuming that you make it all the way up to the surface. The only thing that we're doing here is we're going to play a little ta-da tune on our buzzer. That's that there. And that's the only new feature that's being added that we haven't already had from yesterday. And with that, that is now the end of day 19. I wish you the best of luck today on the way up to the ocean surface. Light speed.
Welcome to the day 19 wiring example video. Well, the big day has finally arrived. All of our designing, testing, and practicing has been leading up to this crucial step in getting home, raising our craft to the ocean surface. Based on the Day 18 project, we now have a design that adds an audio warning buzzer to the encoder and display systems that we've previously worked out. Looking at our breadboard, we can see that the only hardware change from Day 18 is this buzzer right here. And we can see that the buzzer is connected to the Hero at output pin 10. So pin 10 should be the pin in our sketch that drives the buzzer function. And so you can check that and make sure that that's the case. And you'll also see that our buzzer has to have a ground connection. And we're just using the same common ground bus connection right here on the bottom side of our breadboard that's already being used by the encoder and the display. The really substantial changes today mostly involve the software sketch. Last time, when we were simulating and practicing, we could afford to make mistakes and then just go back and try again until we got it right. But this time, we'll need to be extra careful not to irreversibly damage our craft's drive systems and hull, and hopefully get it right on the first try. Because of this, the importance of this particular day's project, our sketch has warning logic built in that is intended to alert us, both audibly and visually, if we are ascending too fast. And it will also tell us when there are planned pause points in the ascent that we've reached. Now I'll go ahead and run my simulation of the real thing so that as you're watching, you'll know just what to expect when it's go time for your run to the surface. So let's go ahead, load up the sketch, and see how it goes. So I'm going over to the IDE now, loading up the sketch. In just a moment, we should be running. And there we are. Okay, so our sketch is running, and our display is indicating that we are currently at a depth of 60 meters, and we've got to get up to the surface when our depth meter reaches 0. So if everything's ready to go, let's go ahead, put our hands on the controls and see what happens. So as I start to rotate the encoder, you can see that I'm decreasing the depth. I'm rising up, in other words. And if I go a little too fast, I get my fingers slapped a little bit because Going up too fast is putting too much stress on my drive. Okay, that was too fast. Still going up. Okay, I've reached a hold point. All right, so I reached a hold point. I was still going a little fast there because you can see I overshot the hold point. If I wanted to, I could go back down a little bit, but let's keep going up and see what happens as okay, that was too fast. And any time now, there I've reached another hold point at 15 meters. Okay, after pausing at the hold point, let's keep rising, up, up, up. And we should be close enough to the surface now. Oh, that was too fast. We're almost there. 5, 4, 3, 2, 1. And we did it. We've reached the surface. So, of course, that was just a simulation of what you're going to do for real. But it's just as simple as that. So I wish you good luck, and we will see you topside after you've made your way out of the depths, and then you'll be ready to prepare for the next part of the journey home. See you then.
Okay, Explorer, the time has come. All our preparations have led us to this point. Our ascent out of the murky deep and back to the surface of this uncharted ocean. We will slowly ascend from our current depth at altitude 0 to the ocean surface of altitude 100. The key word is slowly. We must proceed cautiously to prevent an explosion, which will surely put a hasty end to our journey. On my mark, Explorer, start turning the rotary encoder and let's begin our ascent to the surface. Slow and steady. Engage. All system status clear, keeping tabs on gyroscopic thrusters. Pressure values well within acceptable limits. Steady on, Explorer. 50% slow your roll, Explorer. The ship's pressure is reaching its limits. We need to stop for a moment. Occupy your mind with thoughts of the world beyond this frighteningly vast ocean. A world filled with more breathable air and fewer leviathans. Pressure is within optimal levels. Please continue to turn our encoder and continue the ascent. "75%. You're 3/4 to the top, Explorer, but don't lose your patience. Halt your dial turning for another few moments. We're almost there. Sensors indicate light is coming through much more clearly now. Okay, pressure dropping. Crank that encoder, Cadet. You've done it, Explorer. You've reached the ocean surface. I'm in awe, Explorer. What an extraordinary achievement today. We've navigated our way from the murky depths to the magnificent spectacle of a sky teeming with distant stars. The view is simply mesmerizing, isn't it? Our collective efforts have truly paid off. And look at that. The communications with the mothership have stabilized. I can almost feel the stream of signals pulsating through the system, each beep echoing the missed inquiries from headquarters. They must be on tenterhooks awaiting an update from you, eager to hear that you're safe and sound. It's time to let them in on our victory, to share the wave of hope that's been washing over us. Take a moment, relish this feeling, and then let's send a reassuring beacon back home. Oh, I could just leap with joy, Explorer. What a day! What a triumph! Lightspeed to you. And remember, every star in the cosmos is a destination waiting to be explored.